Yeah, now you see me. What about that? Hmm? Okay, so uh, we have made this quick introduction for those of you that never before used Arduino. So I have to say it's the first time we make this like live streaming like this. We have that live streams before, but right now we migrate everything to completely open source software. We're using OBS for those of you that are interested. That's why we started a little bit late because we never use the system actively, even though we prototype stuff. So, you know, it's demo effect. But we're really happy to be here contributing to the Unleash Lab. I hope that many of you connected because you read the blog that we posted, the blog post that we posted last week. So right now, basically, the thing we're going to do is to make a quick introduction to Arduino for those of you that don't know. And you're welcome to ask questions to the chat, and I will take the questions that I can. This event will last more or less for an hour, and the session will be recorded and will be made available mainly for those of you that are in the Unleashed chat. Okay, so feel free to ask any questions you want to through the chat, and I will do my best trying to answer those that are relevant for the event itself. So I'm gonna make, as I said, this Arduino introduction for beginners. I know that many of you working at with the Unleash event are going to be prototyping something, and that this something might or might not have electronics, or might not be 3D printed, or might not, you know, you might just end up doing something on cardboard, or you might as well build something that includes technology. As you know, we have contributed with some technical help and borrowing some equipment, and even lending some and giving away some equipment to Unleash and so on. So it's important for us that you understand how you can get access to the technology, but also how you can use the technology. So therefore, this seminar. So just to put everything in context, my name is David Cuartielles. I'm one of the founders of the Arduino project, together with Massimo Bansi, Dave Mellis, and Tomaigo. I've been working with this project for the last 12 years. Right now, I'm working with education. The intention of this seminar is, on the one hand, of course, to get everybody that are Unleashed to get started, but also to connect people from the Arduino community that are sitting everywhere in the world that might have an interest in the Unleashed community and the Unleashed projects, and open up the conversation on the Arduino forum for those of you that want to contribute with technical expertise to some of the Unleashed projects. So let's get started. So for those of you that already know about Arduino, please, you know, as I said, this is a beginner's seminar, so I hope you will understand. Some of you might have heard about it. Some of you might even have used it before. So I'm going to say some things that might already be known by you. And then I will even make a logotype. Christopher, who helps me, he just left the room. He helped me setting up the whole thing, and he has brought me an Arduino Uno that we might use as well in the transmission to just make some live demos. I'm going to risk my life here. I'm going to make live demos and everything. It's going to be insane. Okay, so let's get started. So I'm going to just change screen, and here you go. So I'm going to use this slideshow here, and it's a slideshow that I will probably share with you later. So it's a pretty simple slideshow that includes some comments and ideas about how Arduino works and what Arduino is all about. Okay, I see that we have the first question from that's asking about whether anybody speaks German. Severox says, kann jemand Deutsch, wenn ja, ich brauche Hilfe. Well, Severox, you should know that the Arduino forum does have a whole German community where you can go ask questions, but we'll talk about the Arduino forum later. I just, again, hello and welcome everybody to the seminar. People are connecting from, as I see here, Venezuela, from Austria, from Italy, from obviously people that are sitting in Denmark right now, working with the Unleash. So yeah, let's get started. So the first question, in the agenda, we're going to first see what short introduction. Well, I just made a short introduction about Arduino and about myself, and then we will see something about what Arduino is as technology-wise. I will just make a quick comment on how to write code, and I will just present the very simple concepts about digital signals and analog signals. And under the more paragraph, I will make a quick demo with the Arduino Uno that I have here, and then I will as well try to show you alternatives on our different IDEs and so on, and as well answer any questions that might pop up. My goal, as I said, is to connect people that are already familiar to Arduino with those that aren't, and invite you all to use the forum as a tool. And if you're interested in the specific ideas behind the Unleash event, you know, about social innovation and building eventually new inventions to make a better world in line with the United Nations missions for the following years, we will open a technical forum on the Arduino website for, or we have already opened a technical forum in the Arduino website for all of you to contribute and collaborate. So I will talk quickly about the Arduino platform. The Arduino platform is something that we started 12 years ago, to be precise, in March 28th. We met at the design school of Ivrea in Italy, and we had been working in different projects, both Massimo and myself, doing different things, and we designed a circuit board and software to it that was all open source, as it was also based on other open source projects, and we started sharing everything around it with everybody around us. So this platform is made of hardware, which is the board that many of you have in your hand at this point. Hardware evolves over time, so but we try to figure out ways that will standardize the way people would look at hardware. And in order to do that, you need to have pretty good documentation and pretty good software. So all of the Arduino materials, the official ones, are gathered around the arduino.cc domain. We took the .cc because it stands for Creative Commons, and under this domain we gather all sorts of information about how to use the boards, people's projects, but we also try to enable the community or empower the community to bring up a discussion about how things can work and how things can be better. And therefore we built the Arduino forum, as you see there. That will be the tool that we will use to get people to communicate. On the other hand, we have things like the getting started part of the website, or even a store right now where people can look at how to get different things. As you know, Arduino has a physical component, which is the Arduino boards, and in order to get them, you need to get someone to help you with that, and you can get them from many different places in the world, directly from us or from distributors all over the place. Okay, so besides the Arduino boards, we have the Arduino software, and the Arduino software is it's an application that runs in every operating system, and the idea is that it can be ported between operating system iterations and so so the Arduino boards, they have 13 pins that can be used as digital inputs, and 6 pins that can be used as analog inputs. All of the pins can be used as digital outputs, as digital inputs, but only 6 of them can be used as analog inputs. And we will talk about that later and how that works. On the board you will find that there are several LEDs. There is an LED that is used for power, and this means basically that that LED will be lit as soon as you plug the board into your computer. That light should be green. And then there is other LEDs that are used to indicate, for example, there is a data transmission between the computer and the board. And finally, there is a an LED that in the slide is labeled as pin 13 LED, and all of the Arduino boards have one small LED light that will be used to indicate or to be controlled by software, so you can just change things around it. There's a reset button, and that reset button will restart the program. You should know that the microchip on the Arduino boards is made of flash memory, which means once you program it, it doesn't lose the program when it loses power, so you can make a standalone device and have it separate from a computer. So Arduino boards can be used both to be connected to a computer and use the data to control something, but it can also be used detached from a computer and be used by themselves to control something. So this could allow you to, for example, build an irrigation system somewhere and let it running, or build a machine that will have a small screen to indicate people about the temperature outside, or whatever you want to, and you won't need the computer to do anything about it. It could also be possible to just use the big microchip on the board by itself on top of your own circuit and build your own system. And this is one of the powers of the Arduino system, that you can decompose the hardware and make your own and use the same software to program it and so on. So if you think the Arduino board is too big, you can always use a smaller Arduino board. There is different form factors, but you can as well just take out the chip, put a battery on it, and put it to work. So that, just keep this in mind when you're thinking about what you're going to design in the Unleashed challenge, that you can always think about how to recompose the hardware in multiple ways. So then, talking about the Arduino IDE, here you see a screenshot of what we call the old school Arduino IDE. It's made in Java. Java, for those of you that don't know, is a programming language that can work in every operating system. That's why it's made in this way. So with this IDE, you can install it in Linux computers, Macintosh computers, and Windows computers of any kind. And it runs with operating systems that are as old as 5 or 6 or 7 years old. So let's say that you were, for example, thinking about building some sort of a sustainable product that people could be capable of updating over time. So you could always tell them they could change the software even though they had like a 5-year-old Linux laptop running somewhere, So that's very, very convenient when thinking about not just designing, but about making sustainable designs that are going to be used by people over extended periods of time. On the other hand, because time changes, and we see more and more usage of more powerful computers that are making use of browsers all the time, and they're always connected and use the cloud, we at Arduino have created something new that is called the Arduino Create, which is an online system that can be used to program microcontrollers without having to really install almost anything in your computer. So if you are considering the idea of using state-of-the-art technology to build something, you could just become an Arduino Create user. In order to become an Arduino Create user, instead of downloading the software, you register on the Arduino website and you just download a small client that will help you use the system. It can also be used offline, but it's a lot more convenient to use it online. So if you have the opportunity of working online all the time, I totally recommend you change to use Arduino Create, because it's a lot better. You get a lot better user experience, and for example, it has all of the libraries that you need already installed there. So you don't need to be downloading extra libraries and doing different things. So there's different scenarios of use. Let's say they're going to be in a completely offline scenario with all computers and so on. The old Arduino IDE, the classic one, is very, very good. On the other hand, if you're going to be in an always connected situation, the new Arduino Create is a lot better. So you just have to balance and choose the best option. Anyway, for the Unleashed challenge, feel free to take whatever you feel is best. Just talking about the basic functions on the Arduino IDE. Now, most of the pictures are going to refer to the old Arduino IDE, but please, you have to understand, I mean, they are the same. So both of the functions work in the same way. So the basic Arduino IDE has a set of functions that are the ones that you use the most. They are put together in this toolbar that you see on top here, and this toolbar has only 6 buttons. That makes it very, very simple for you to work with. So you have verify. Verify will take a look at the code. The code that you write for Arduino boards is C, but it's simplified in a sense that we have functions that have human readable names. So you will see it now in the examples. We have a another button that is upload. So upload first checks out the validity of the code, and then it sends it all the way to your board. Then we have new to create a new piece of code. We have open that will open a new file, save to save your current file, and serial monitor that will open a window and will allow you to monitor whether the program that's running on your board is working properly. Those are the buttons that you use most of the time when you're working with microcontrollers. On the other hand, there is a menu where there is other options that will allow you to install new libraries, install new definition files for new boards, because there is not just one type of Arduino board, there is many types of Arduino boards, and so on and so forth. So if you want to start, and I will make a live demo of this, but if you want to start working with an Arduino board, as you see here, you might have different operating systems, and I will recommend that you take the opportunity of trying an example that is called Blink. Blink is the easiest example that you can do on Arduino, and it can be, I mean, the idea behind it is just make the LED on the Arduino board blink and change from being on and off depending on a timer. And the idea there is to just learn about how you can turn on and off a physical pin using a digital signal. It is really that simple. Okay. So the one big difference between computers is how the Arduino board shows up in your computer. You know, because the Arduino board, as you see in this board here, right, is connected to your computer using a standard USB cable. The different Arduino boards, they always use USB cables to connect to computers and change the software. There's some new boards that can be changed over Wi-Fi eventually, but this is not the one I'm showing in this example. So once you connect it to your computer using your USB cable, the first thing you will see is that the LED on the board will turn green. In case you don't see this, I will just give you a larger image so you can get the idea of what is happening. There you see the board, and there you see this LED down here is the power LED. Okay, here's the board. This is a bit of an older model of the Arduino board, but it's functionally works exactly the same as the ones that you guys have, just has a different silk. And you see that there's a light here that is blinking on and off. This board is running the basic blink example I'm going to show you. Well, when you connect this board to the computer, the thing that happens is that this board is identified in a different way in your computer depending on the type of operating system. The operating system knows, yeah, this is an Arduino board. That's no problem at all. But the thing that changes is that the name of the port is different between operating systems, and that's what you can see here in the slide. So if you have a Windows computer, the Arduino board will show up in a port called COM something. The something is a number, and that number changes depending on the board that you connect to your computer, how many boards you have to connect to your computer. So it takes the latest available port in your computer. So you could have it in COM3 or COM5 or COM7 or COM17. It depends on how many things you have connected to your computer. If you have a Macintosh computer, you will see something like /dev/cu.usb modem and a number. And again, that number depends on different factors, and in this case is in the manufacturers of the chip that does the USB to serial communication, the communication to the board, basically. And you have a Linux computer, like I do in this case, the USB port will show up as /dev/ttyacm0. 0 for the first board, 1 for the second board, and so back and so forth. So it's very important because when you start looking for examples online, people will tell you connect to the port COM3, but that means that they had a Windows computer. If you happen to have a Macintosh computer, you will not have to look for COM3, you will have to look for something else. Okay. Before I continue to show you the live demo of the example, I would like to show you a bit of the idea on how you should think about coding. So when you write an Arduino program, you can, it's C code, as I said, you can write it however you want to, but it's recommended for your own well-being, because you will look at these things later, to give it a bit of structure in the way you write code. The example you see here on the slide is the example called Blink. That is the one I was talking about, that will help you to make a light go on and off at a certain pace. It's the one that you saw on my board that I was showing earlier, the one that was running here. So you see the light is going on and off once per second, and that's basically that one example. So it's good practice to separate your programs always in the same way, so it's easy to find stuff and so on. So Arduino programs, they always need to have two functions or two blocks of code. One is called setup and the other one is called loop. Setup is the part of the code where you will write your configuration code, for example, to determine that the pin is going to be an output. For example, to determine that you want to use communication towards the computer so you can check that your program is working properly. On the other hand, there is the loop, which is a part of the program that you're going to use to repeat functions again and again. As I said, the board here, the chip here on the board, is the microcontroller is a small computer. This small computer is working at 16 megahertz, which means it's making 16 millions of operations per second. And in your program, it's making those operations again and again, one after the next, forever, until you plug off the thing from the computer, or you turn off the battery, or there is a nuclear disaster and the board burns, which will most likely not happen, hopefully. So the code that will run again and again is the code that is inside the loop, while the code, while when the board starts, it will go through the setup and initialize everything and make sure that everything is ready for when it starts. But if you press the reset button on the board, remember I told you there is a reset button. So if you press the reset button, then it will go back to the setup and then restart the loop. Just keep this in mind. So in the code as well, you might be using global variables, which is a very common thing to have in order to store information that will be changing eventually throughout the use of the program. You should declare the variables in the beginning of the code so you can see them clearly. People can see, oh, he's using a variable to store the temperature, using a variable to do this or that, and then refer to them later in the program. In this example here, you see that we have a variable which is an integer number, and we call it LED. LED is the human readable name of this variable, and we assign it the number 13. This means that every time we write in the program the word LED, it will represent the number 13. So in setup, you will see that there is a function called pin mode, and the function pin mode, what it does is to determine that a pin on the board is going to be considered of a certain type. If you call pin mode, it's almost sure that this pin is going to be a digital pin, and you can determine whether it's going to be an input or an output. So pin mode LED output is basically saying, take the pin number 13 and make it into an output. At this point, I have to go back to the board and show you how the different pins on the board, they have numbers. Let me just show you the other camera. Here you can see, and you can see how the different pins of the boards, and then pin 13 is also physically linked to the LED, so that when you change the via software, you change the value of pin 13 with a function, is also affecting the physical port and is eventually putting a voltage there. So let's see how this would look like in code. In the example Blink that I was talking about earlier, as you see here, we have pin mode, which basically is assigning a pin to be an input or an output, and then we have the function called digital write, and digital write is telling to a pin, write high or write low. And writing high means write the voltage into that pin, and if you work with Arduino Uno, writing the voltage means put 5 volts on that pin, and if you say digital write low, it means put 0 volts into that pin. And you see here that you in the loop, what we are doing is to turn the pin on, which means put 5 volts in the pin, wait for 1 second, and then write the pin low, which means put 0 volts on the pin and wait for 1 second and repeat. And that's what is happening on this example on this board here that I was showing you earlier, where the light is going on and off. We're basically writing the pin with 5 volts and then with 0 volts, which basically turns the light on and off. So this is the super basic example, the absolute beginner's example to Arduino. So you went online, downloaded the IDE, or just logged into Create, and then install the software, the drivers or whatever. You plug in the board, identify the board, open the blink example. There's a tab with examples, and you will see this examples blink, and then you can upload this program, and that's it, and it works fine. So the LED that you see on the board is a typical surface-mounted LED. If you are working with some of the materials that we lend to people at Unleashed, you will realize that there is a bunch of LEDs. A typical LED you might be using is this 5mm LED that has one flat corner, which happens to be the so-called negative pin. So if you want to make a test, you could take one of these LEDs and plug the long leg on pin 13 and the short leg on pin 0, or 0 volts, which means ground. And in that way you could test the same thing with a larger LED. So many of the prototypes, you end up designing some sort of physical shape that is going to indicate something to people. If you think about making something extremely cheap, you might not use a screen, you might just use some LEDs to make it work, and just want to indicate status for working and not working. So you can just plug in LEDs in this way, and put them anywhere you want to in your prototype, add wires to them and plug the wires into the Arduino pins and make the thing work. So this is a very, very simple way to get started, to show something working in a super simple way. Okay, so that's about the very basic introduction to Arduino. So I'm going to give you a really quick demo. For doing that, since I'm using this system, I have to open the Arduino IDE in my computer, and then I have to assign the Arduino IDE to the window I'm using. It's going to take me 2 seconds. I can do it as I talk, but please feel free to ask any questions about what you have seen so far, or whether you have any questions. And if you happen to be an advanced user that is in the streaming, please also don't hesitate to ask questions. I will try to use a language that can also work for beginners, but I will try to address whatever question you have. So we have another 25 minutes or so of streaming, so please feel free to formulate any questions, or if you have like a project idea, it will be very easy for me to get started and help you out. So I'm going to open the Arduino IDE in my computer, and then I will make sure that you can see the Arduino IDE on your screen. And remember that I have the board here connected. I'm gonna open the blink example as I was showing you earlier, and I'm going to modify it live. So that's my idea for the next step. Okay. You don't see this, but right now I'm going to, on the Arduino IDE, I'm gonna just change the typeface size because I have it on a really small typeface, so make it impossible for you guys to see it. So I'm just changing that very quickly on my computer. I'm doubling the size from 20 pixels to 40 pixels, so you can much easier read what it says in here. And okay, that's done. And now I will go to the streaming device and just tell it to change the window it's using. And here it is. Okay, here you go. So now you see the Arduino IDE out there on top of the slideshow. I made the typeface, now I look at it ridiculously big. Okay, anyway, this allows you to read exactly what I'm typing. When you open a new sketch on the Arduino IDE, this is the Arduino IDE that works offline, made in Java. I typically work with that one because I work with a lot of development projects where it's not possible to have a really good connection and so on, and we're tied up to use this one. So for example, it's very easy to wrap a Linux distribution for users to have that has the Arduino IDE inside. So we do that typically when we work with education in developing countries, for example, to serve them a fully working system. They can just put in a USB stick and run on any computer and start working right away. So this IDE is the latest version, it's 1.8.3. So it has all of the latest features, and I have installed a lot of libraries. I use it and misuse it as much as I want to. And so I'm going to make the Blink example. Before I start, since there was a question from Sergio, I want to answer this question just to try to empower you guys, to try to get more questions from you. So Sergio is asking, David, at your home, do you have any Arduino project? Well, at my home, I used to have one Arduino project in my kitchen, but we changed place recently. But I used to have a rainbow in my kitchen with some of these addressable LEDs. So I had a rainbow lamp in my kitchen that was constantly broadcasting a rainbow. I live in Sweden, and the winter is a little bit dark, just saying. So my daughter told me when she was like 4 years old that she was like, would like to see a rainbow. So I made her a rainbow, and we had it in the kitchen for 3 years, non-stop. It was really fun to see. Though my girlfriend sometimes was getting nuts about an ongoing rainbow there. But right now we changed place, and I'm actually automating part of my garden. So it's very easy to use, Arduino to time, for example, irrigation systems, or to measure the amount of light to decide whether you need to add extra light to your plants or things like this. So that's the one that I use. I'm working with right now. Plus a bunch of robots that we use for education, but that's a different story. Okay, so let's look at the example here. So as I told you, I'm running Linux. So in Linux, in the Arduino IDE, you get the menu on top of the program. If this was a Macintosh computer, for example, you wouldn't see this here. It will be on top of the window. Okay, and let's say I click on File. I click on File. By the way, the Arduino IDE in my computer is in Spanish, but you will have this in the operating system that you have by default in your computer. You can see right now the action that I'm doing. For some reason, this system is not capturing the pop-up, but I'm going to File, Examples, and then under Examples, there is another pop-up that's called Digital. Under that digital example, there is the possibility of opening an example that is called Blink. And with that Blink example, you will get the code that you saw earlier. So sorry, and I said digital is basics. So it's examples, basics, Blink. And then you will see the following code. Okay, so this is the code that you saw on the slide earlier, and the difference between this code, the text font is so big that I will have to make it a bit smaller so you can guys get to see something. Okay. So the first thing you see, if you have never programmed before, you can add comments to your code so that you can remember what things are all about. It's really hard to look at code and understand really what it does. So if you are not the person that made it, and even if you're the person that made it, when you make a program, many years might happen between the moment you make it and the moment you look at it again. Like I wrote the first Blink for Arduino 12 years ago. And it's important that you keep comments there to explain people what the code does. So you can write comments at the beginning of a program, and you just use a special command, which is like /*, You can write anything you want to, ending by slash asterisk slash, and this means that you can put anything you want to there, and the compiler will not look at it. So you can even write things that are inconvenient, you know, like bad words, and the compiler won't care. You know, I work as a teacher at the University of Malmo, around the corner here, and I can find sometimes really funny comments from my students, like, "Oh, I hate this programming class," and the compiler won't filter that. It would be really cool to make a compiler that did that. Okay, so this is another type of comment with double slash, and this line is again to tell you, okay, this is a tab, and this is doing this or that. Setup has the pin mode function that will make a certain pin into something, either an input or an output. And you see here is this example is calling LED built-in. LED built-in is a constant in the Arduino system that determines which pin on the Arduino board you have has an LED attached to it. Because on the Arduino Uno is pin 13, but in other Arduino boards it might be a different pin. Or you might be using whatever, like say another fruit board that has happened to be putting this LED somewhere else. So, well, I see that some people are saying that they don't hear me. I have this microphone in front of me. I cannot get in any closer. So I hope it's just a streaming problem having to do with YouTube right now, and it's just happening to you. I'm really sorry. Okay, so as I said, this will mean pin 13, LED built-in. We'll make that pin into an output, and then we will turn the LED high, which means we will put 5 volts, or turn the LED off, which also to low, which means we put 0 volts. As you can imagine, if you put 5 volts into a lamp, the lamp lights up. If you put 0 volts into the lamp, the light goes off. That's simple. Delay 1000 means wait for 1 second. Delay needs the time to be expressed in milliseconds, so 1000 milliseconds is 1 second. So in the loop, the program goes turn something on for a second and turn something off for a second. You know, that's simple. So as you see up here, the buttons, the first button is verify. If you click on verify, it will check that there is no errors in the code. If I click on verify now, it will try to compile the code. Well, first it asks me if I want to save it. I do it, and tries to verify the code, and if there is no problems, the program will be compiled, and you know, it says here compiled, in Spanish compilado, and that's it. There was no problems. Let's say I make a mistake intentionally, like I don't have a semicolon at the end of a line. If I click on verify, it will complain. There's a lot of red text. This red text here does not correspond to the error. It's a warning because I have a certain library, but if I go farther down in the error, I will move the window a bit farther up so you can see it. So if I, one second, I have to do it in this other window. So if I move the window up, now you can see, you see, it says there's an error. I expected a semicolon before a curly bracket. Since there is no semicolon at the end of the line, it detects the error and it spits it out and tells you, okay, you need to fix this. Okay. So I just show you how this works. I have a technical question that I'm going to take it right now before I continue. For those of you that are more technically inclined, you might be interested in knowing, as Sergio asked here, how we compile the program without the IDE. Well, it is possible to compile the software with directly command line. The whole Arduino IDE is made in Java, but is separated from what we call the toolchain. The toolchain is the part that creates, or that takes the text, because the code at the end of the day is nothing but a piece of text, takes the text and makes it into binary or machine code. That is what runs inside the microprocessor. And that can be called from command line. And there is a lot of explanations online on how you can do that. So for you, Sergio, that asked this question, you can just Google Arduino compile CLI, as in command line interface, and you will find a lot of solutions for that. There is even a Python tool that allows you to very easily call multiple boards that I use for a European research project where I reprogrammed 20 boards remotely using a single command line stroke. So it's possible to do a lot of these things if you want to automate processes or use your own thing. Okay, yeah, but again, as Mr. Deepcat says, the whole Arduino IDE works using AVR GCC, which is a version of GCC that compiles AVR code. AVR is the chip we have here. If you had a different type of Arduino board, there would be a different toolchain, but for the Arduino Uno, it's AVR GCC. Okay, so I have this example here, and as you see here, my board is right now blinking once per second, which means it's running exactly the example you have here. I'm going to change it so you can see a change in the board. So I will just make it work so that it blinks a lot faster, so that the light will be on for 200 milliseconds and off for 200 milliseconds only. Okay, so I'm going to click on upload, but before I can click on upload, I have to make sure that my board is on the tools menu is registered properly. So you cannot see this because for some reason the system is not capturing this image. But if you click on the tools menu, as it says here, herramientas in Spanish or Werkzeuge in German or whatever, at some point it says board, and you have to make sure the board is ticked as Arduino Genuino Uno, and then that the port corresponds to the port in your operating system. If you have Windows, it will be COM and a number. If you have Linux, it will be /dev/ttyacm and a number. And if you have Macintosh, it will be /dev/cu.usb modem and a number. But the feature on this Arduino IDE is that besides the name, you will see between brackets that it says Arduino Uno. This means that you don't need to really try to figure out which is the right port. You will see it on the IDE, and if you don't see that, that means that you might have to check that you have the latest Arduino IDE, or you have to check that your board works properly and so on, because it should show up there. Okay, so if everything is fine, when I click upload, you will see how I forgot to put the semicolon. I provoked a mistake by myself and forgot to fix it. Okay, now if I click upload, you're gonna see how the two lights blink here, which those are the lights that are responsible for the communication between the board and the computer. The other light, the light on pin 13, is blinking a lot faster. That faster blinking is a change that I just made in the code. So you saw how I directly changed the code, and that affected the way the board works. So as you see, it's very, very simple to get started and do different things. But right now, I would like to go back to the conversation about what other things can be done. And for those of you that are starting, I think you need to understand that not only can you work with turning on and off lights, you can read signals from the world. You can do things out of this in multiple ways. So first of all, we just talk about digital signals, just to recap. So you can turn things on and off. You can turn a light, a small LED, but you can turn a light in the system. You can turn on a motor, anything you want to. Just using the right interface. If you want to move a motor using an Arduino board, you might have to use a relay or a MOSFET transistor or whatever, right? You can also read different signals. So you could read buttons as input. So you could have a button that you plug to a pin, and you can detect that somebody presses the button. That is very simple. You can also read analog signals. The word is not digital. The temperature is not on or off. The temperature is cold, very cold. Actually, we express the temperature in degrees. Like temperature can be 0 degrees, 5 degrees, 10 degrees, and for measuring those kind of things, we need to work with analog signals. Analog signals can be measured in the Arduino board using the 6 analog pins that will transform a voltage at the input into a number. So if you can transform any physical property into a voltage that is between 0 and 5 volts, that means that you can directly read it in the microcontroller and use it as part of the code. Okay, so then there's different types of sensors that can transform all these different physical properties into numbers. For example, there is LDRs that can transform light into a number, or NTC components that can transform temperature into a number, or a potentiometer that can transform an angle into a number. And as I said, the idea is that these physical properties will transform into a number that will always be between 0 and 1023. For example, if you have a temperature sensor, you can, when the temperature sensor gives you 0 volts, this means that will be transforming number 0. And when the temperature sensor gives you 5 volts, this means it will be transforming number 1023. And everything in between will go in a proportion. So the only important thing is try to understand how these sensors translate the physical property into a voltage. And that's something that you have to research. But there is plenty of information out there, and that's what the Arduino forum is for. And this basically links me as a way to close my presentation here to the fact that I have to show you where we expect the Unleashed community meet the Arduino community that is on the Arduino forum. In order to access the Arduino forum is completely open, but in order to be able to comment on the Arduino forum, you will have to register on the Arduino website. Of course, it's entirely for free, and it will take you 5 minutes. And I really would like to see how people come and contribute to this. So I'm going to open here a different window in the browser where I will just go to the Arduino website, arduino.cc, and I will open the Arduino forum. Here you see the Arduino website. You don't see the full website. I'm going to just quickly change the properties of this so you can see the website as I see it. Yeah, like this. So there you see there is forum up there. If you click on forum, this is link me to an entirely different window. I'm just going to make sure that this is the right window. One second. Yeah, this one. Okay. This is the Arduino forum where you can see I have plenty of messages. I will just look at those later. And you see here's the Arduino forum, and the Arduino forum is a place where Arduino users meet to discuss about a lot of different things. There is over 400,000 Arduino registered Arduino forum users, which doesn't mean there is only 400,000 users. There is a lot more users. The Arduino software is downloaded once every 2.6 seconds. That can give you an idea of the dimensions of the Arduino project. And we have created special discussion board just for the Unleash event. So I'm just looking for it. Development, moderation. Here it is. If you go to workshops and events, we have created a special board called Unleash 2017, where we hope people from the Unleash project will meet people from the Arduino community and come and discuss. So far, there is no messages. There is just a forum purpose message that we posted. But you should know that this forum is open for people that are working with social innovation projects. They can come here and explain about their issues, and we will come in and help you out. Personally, I will be attending this forum and help you with any kind of thing from concept to realization. So this means that if you want to know whether you could perform a certain task using electronics, using an Arduino board, please feel free to ask, even if it's more conceptual and also technical. We will be very glad to contribute and help you out. Oh, I realize now I'm just showing you, I'm not showing you the right window. Here it is. So I will just do again the how you come to the forum, because I just realized that I was talking about how you come to the forum but not really showing you because I didn't activate the right command on the forum. So so if we are on this window, 1 second. If we go to the Arduino website, I will start from scratch again, arduino.cc. Here we go. And then it's strange, my computer is showing different things, so you don't see what I'm seeing. So I'm going to just make sure you see the right thing, but I guess you get the idea. Okay, this way is better. And now, so now you can see my window, and I will just quickly guide you again how to make it in the forum. So you make it to the Arduino website. Once you're on the Arduino website, you can see the forum, and if you scroll down in the forum all the way to I went through it. Workshops and events. In workshops and events, you can see there is the Unleash 2017 subboard. You can click on it, and in this board, we expect people to come in and post their ideas for projects, as well as technical issues they might find. So when you click on it, the forum purpose, you will see how Jake, one of the Arduino project managers, posted, which is the purpose of this forum, for you to start working. But you can add not just answers to this forum thread, you can also add new threads into the Unleash 2017 line and start asking questions. And I will monitor it personally, as well as volunteers within the community. So please feel free to start using this for your project development. Okay, so now it's time for some questions. You have 5 more minutes. So you have some questions, please feel free to ask, and I will answer them. I think I will start with the first question that we have here. I think we have 2 different questions from the chat that I will answer right away. So the first question is oh no, first question is already answered, we did earlier. Second question is from Mr. Deepcat. It says, hi Arturo. Well, I'm not Arturo, I am David. I think you said that because you saw that in the code. The first name says Arturo. Arturo Guadalupe is a developer that works for Arduino since some time now, great guy. He's been supervising a lot of the examples on the IDE, and that's why he gave his name to that example, even though I said that I made it 12 years ago. Arturo is the current maintainer, so that's why you probably got confused. I am working with a multi-threading and event-driven thing. Any official library you can recommend? If I'm not mistaken, Concurrent is a library for multi-thread. We can check that. I can check that as I talk. I will open the Arduino IDE in my computer. But it's a library maintained by one of our developers, or was maintained by one of our developers. So you can totally check that out. But there is several concurrent libraries. The only thing with concurrent libraries is that you need to make sure you look at things that are that have the exact control of interrupts that you want for yourself. You know, if it's something that works very slow, then it's fine. But if it's something that is faster, you have to be careful. And if what you need is something like a real-time operating system for things like I don't know, let's say a robot, for example, I recommend that you take RTOS, look at RTOS libraries, and that you take a look at using an Arduino Zero or Arduino Due that can run pretty good RTOS and do much faster things than the Uno. The Uno is a great tool for simple tools that you want to put out fast, you know. And but if you want to do like complex, super high-speed things, you should consider using Zero or Due. So please, while I look for this, feel free to ask any other questions. Otherwise, I think we'll call it a day. So since you asked, there is in the Arduino IDE library, there's one called automation. And this automation library is a multitasking table-driven finite state machine framework. An event-driven framework that allows you to create Arduino applications that consist of concurrently running state machines interacting with each other. So this might be interesting for you. Just go to the library browser and look for automation. And it's made by Tinkerspy. Okay. There is another question here by Sergio. Which is the most impressive project you have seen made with Arduino? I get this question a lot. So I can answer this question from different perspectives. So if I have to say which is one of the craziest things I've seen, I would recommend that you check out the project called ArduSat, where they made a satellite that runs the equivalent to 8 Arduino boards, and they rent servers, satellite space, like time slots, so that the students can run projects on the satellite on distance from students from high school, and they can learn something about space technology. That's one of the craziest things I've seen. On the other hand, if you're interested in looking at more, you know, contemporary things, or I mean, I've seen Arduino used to empower people, to help people like learn about building their own small systems and automate small workshops and so on, that to me are as valuable and impressive as a satellite in space, right? Because for me, technology is about transforming society. So, you know, almost anything is great. And if I see a 6-year-old kid that gets interested in electronics and builds something that moves and gets excited and understands what he's doing, then, you know, I feel we accomplished something. So, yeah. So it's hard to answer because I like both ends, you know, the super mega technological and the more social one. Okay. So if there is no more questions, I think people following right now is dropping. I mean, the video is gonna be available online. I don't know if today or tomorrow when the whole thing is over. I want to thank you all that came to the seminar today. We had some small technical issues, but I think it went pretty well for being the first time we use OBS. If you're planning on running your own seminar line, I can totally recommend you use this OBS software that runs on Linux, Windows, Mac. And this was David Cuartielles from the Arduino project. So thank you very much, and we meet online, you know, whenever you want to. See you in the forum. Thank you.